So in this particular class, we are going to talk about design factors. What are design factors? For every structure that you design, no, doesn't matter what you design, some things can have some uncertainties involved with that. Some uncertainties are not controllable, as for example, the weather or external conditions. But there are other conditions like human errors, like in a manufacturing process. We may want to have certain dimensions, but we have to consider some tolerances for that. There may be errors as well as during the operation. Um, and you have to take into account all that, all the different aspects of that. Like for instance, in many cases, you may your factor of safety can be very, 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 very small, and it's not a big deal because there's no humans involved with that. By the time you have humans involved, the factor of safety can be very large. In the airplanes itself, our factor of safety many times is very, very, or most of the time, is close to one because we cannot make heavy airplanes. So we have to make sure that we got to the science how the planes actually are designed. In the case of cars, it may not be a big of a concern because if your car, if it's static and it's standing there and it breaks down, it's going to just stay there. Possible accidents are small. However, the factors, dynamic factor of safety, when your car is in movement, it crashes, then you have a human in the inside, you want to consider the factor of safety to be considerable to take that into account. Okay, there are a couple of things that we have to understand when we do that, and let me go ahead and explain that a little bit more in detail. Um, there are many different ways that you can do the factor of safety. There are two things that we talk about. Let me talk first about the design factor. Design factor is what's already given in the problem. This factor typically is a factor we're going to call it in this course ND, and this factor includes all uncertainties, all possible uncertainties in your problem. Okay, and what do you do with the design factor? Well, you take your loads. Let's say I have a shear load of 100 pounds. So what you would do is your new shear load will be 100 pounds multiplied by your design factor, ND. Let's suppose I have a axial load 1,000 pounds, while your new axial load would be 1,000 multiplied by ND. So this is what we always want to do. You take your loads, you multiply by the design factor, whatever the design factor is. Maybe it is the moment, inches pound. Then your new moment, you just multiply that moment by the design factor. Maybe it's the torque. Okay, maybe you have the value of the torque. Then all you have to do is multiply the torque, the value of the torque times the design factor. This is what we do all the time. We take the loads and we multiply by the embedded design factors, and then we move on. What are the design factors? I like what Collins explains. This is one of the best explanations I've ever seen on this topic. And he recommends to use 8 specific factors. And you can pause the video and feel free to, not feel free, I expect you to pause and take notes on these. This is important. It's a good, it's completely fair enough to ask you in the test as well. So here, this problem, for this particular case, Collins suggests there are 8 different factors that we want to consider. It can be how accurate, how much knowledge do you have the loads? Do you have enough knowledge or you don't have enough knowledge? You have accuracy of the stress calculation. When you do your calculations, how confident you are with those calculations. Maybe the stress analysis involves many approximations that maybe you want to include that factor here. The accuracy of the strength and the knowledge of that strength and how the failure is going to be modeled, that's also important. Maybe you need to be conservative. Maybe it involves human life and it's severe damage. What is going to be the type of manufacturing involved with that? The type of conditions, operation conditions, is going to be operating constantly, high weather, severe operating conditions, or it's going to be mild. All depends. The quality of the inspection. Every product needs to have some sort of an inspection, and that's very, 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 very important. So the way we do this is we're going to use what we're going to call rating factors. Okay, the rating factors go as follows. So this is what we call the rating factors. Okay, and the rating factors basically say rating numbers say the following. Say mild need to modify, moderate need to modify, strong need to modify, extreme need to modify. Obviously, if you put a 0, it's saying no need to modify. Okay, to modify your design factor. So what you're going to do is you're going to make a scale, okay, and the scale is going to go, you're going to have a scale from -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, and then once you have that, you put a scale there, then you're going to give that factor to each one of these guys over here. And as for an example, we're going to do this, we're going to do an example letter, but just to give you an idea how this actually is going to work. Let's suppose these are the factors I put in there. Okay, so for each one of the cases, I put a 0. I put anything from 0 to +4. I just put a value there. Okay, and depending on the value I put in there, then what you want to do is your T is going to be the summation of all these numbers. Okay, all your RNs to 8. Then what you're going to do is, what you're saying is that your design factor is going to be given by this equation, 1 plus 10 plus T squared divided by 100. Okay, for this, so this is what's going to give you what your design factor needs to be. In a typical case, so it's a very systematic approach where you just go and make this table and say, I have all these cases and this is going to be my design factor. And you want to understand what these do, and this is what you, and then you just plug in the values in there. Typically, this is how you would do this, but typically you don't want to use negative values. You just use all positive values, and that should be also good enough. However, one may cancel the other, and that's how you do it. Okay, but now the other thing that you have to, typical values that you may want to consider, they're very common in the aerospace, in the machine design, depending on, it doesn't matter wherever you go, are the following. So again, you're more than welcome to pause this and go over this material. So these are some typical design factors. Typically, I want to the range of 1.25 to 5. Very commonly, 1.5, if you don't know anything about the problem, then you can just really using 1.25. In many times, just using a 1.5 would do it. Anything above 1.5, you're really talking about when your environment loads, or it's a very critical part to the business, to the problem you're doing. Like for instance, the landing gear of the airplane, you might need a high factor safety just because it's the landing gear. It's what's going to hold the plane when it is landing. Many times the impact factors, we may have anything between, we usually multiply anything that's impact probably by 3.3. 3.5, 3.3, that's a typical value here for the impact factor. When you're working repeated loads, we will learn how to do that. We also fluctuates about 3, sometimes 2 to 3. So it really will depend on the type of application that you're trying to do. Okay, so in other words, in a nutshell, what you're really trying to do is you're trying to find a design factor. This is either given or it is calculated. Okay, either way. And the end of the day, what you want to do is you want to take the design factor, multiply your loads by the design factor. This is your new load that you're going to use for analysis. Okay, maybe it's the torque. Your new torque for analysis will be this times this. Maybe it's the moment. Your new moment will be the design load times P. Your moment. Maybe it is the shear. The new shear will be the design factor times V. Now, this is what you really have. This is your design factor that's given to you. However, there is something that we need to find, and we evaluate everything. Once your problem is designed, we evaluate the factor or safety factor. The safety factor in the problem is a bit different. It should be seen differently. The safety factor in my problem is going to be my allowable stress is the allowable stress divided by the required stress. Okay, the allowable stress comes from your stress strain curves from the material, sigma times epsilon, and then you typically here you have, let's say, sigma yield. You want to stay below sigma yield, so maybe this is sigma yield, and then this is the calculated stress. Okay, this is calculated. So this is the stress to calculate. This is sigma yield, and you want to find this factor. Remember, this calculated stress, let's say an example, I only have a pure load. This is P over A. The P I'm going to use is the P nu. Okay, it's the load that's already multiplied by the design factor times P. Okay, now this design safety factor has to have various values. Has a value of 1, is bigger than 1, is equal to 1, and is less than 1. Let me explain how this works. Let's suppose you are sitting in this restaurant and you're eating the best piece of steak that you like, and it's the way you like it, medium well, rare, well done, whatever. And you're sitting there, it's very juicy. You take your spoon, you take a bite for that, and you're ready to eat that steak. If the steak hasn't touched your tongue yet, the steak is still safe. So anything that's safe, we say is actually bigger than 0. So there's no safety. There is no failure occurred. So we are talking about your structure is completely safe. Now, I want you to think your steak just touched your mouth. You're about to bite it. You haven't bit the steak yet. You're just about to do it, But as soon as you touch the stake is about to, the failure about to occur on the stake. So it's at the onset of failure. There's no failure yet, it's at the onset. So we call this onset of failure. Okay? And then now think about, you got the stake, you ate it, and the stake is gone. Well, this is what we call failure. So you always want to make sure that your factor of safety in the problem is bigger or equal than 1. This is what we always want. This is the requirement, design requirement. This should be the design requirement in your problem. Okay. If you think about it, what you want to keep in mind every single time, sometimes the additional factors of safety are added from the one that you calculated. So then what you would do is you can have your factor 1, factor 2, factor 3, and you just multiply them. You just multiply those factors together, and that's what you would get. That's, for instance, you did your calculation using this equation, where it said your design factor 1 can be 1 plus 10 plus t over 100. This is t squared. Okay, and then maybe the problem says you need to add additional factor 1.1. 1.1. And then he says if it's a dynamic problem, add on top of that another factor 1.3. So for the example that we did, this is 1.25, then your real design factor would be 1.25 multiplied by 1.1 multiplied by 1.3. So if you multiply that, you get 1.75. So you can just say your design factor would be 2 decimal points is good enough, or many times just, in this case, you can round it up to 8.8 if you wanted to. So this is your design factor. You don't want to just use a design factor as high as you want. More conservative means more material, more expensive everything is going to be, and this world is all about making profit out of your product. And the more expensive something is, the less the people are going to want to buy it. So just keep that in your mind as we move forward and we are doing design and we are studying failure. Failure is measured by factors of safety. Okay, and factor of safety is going to tell me if something's going to be safe or it's not going to be safe. And basically, once again, your factor of safety in the problem is calculated by your allowable, whatever the allowable is, okay? The allowable stress divided by your required stress, okay? I should warn you that sometimes people like to do is, they say that your allowable stress will be sigma yield divided by that design factor. This is one way to do it, but if you do it here, do not add that design factor to the loads. However, when you go to the industry, many times what we do is we just say, hey, we're going to apply this to the load, and we're going to keep this as sigma yield, and this required load is going to have the design factor to the loads itself. So all your loads are multiplied by the design factor. Okay, and this is the approach we will use rest of the course, because I find that more practical, and this is what we really do. Your textbook doesn't necessarily do that. Doesn't always do that, but I would emphasize that within real life, that's what we do. So just get used to that. So this concludes this discussion on factors of safety and design factors.